Grade 12 learners. Welcome to today's geography lesson. My name is Rina van Heerden and my co-presenter for today is Cynthia Zondi.
This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Centre. We are on lesson 7 of 2024 and today's lesson is on drainage systems in South Africa, fluvial processes and Mapwork. The objective of this week is to do some revision on the work that was taught by your teacher this past week. We're going to look at stream orders. What is a stream order? Where those stream orders are, and some interpretation on that content. We're going to look at the discharge of a river, the definition, identification and application. We're going to look at laminar flow and turbulent flow. We are going to look at how it look, identify and where does it occur. Then we're also going to look at river profiles, where you need to define what is a profile. You need to be able to describe the profile, and you need to know what are certain associated characteristics of these river profiles, including the stream load. And with river profiles, we're going to look at the longitudinal profile, a cross profile, a plan view of both profiles, and then the relationship of both profiles to the stages of a river. And you know that the stages of the river is the upper course, the middle course, and the lower course. Okay, let's then, as I said, remember, each week you need to do some map work. So this week is where we're going to compare the orthophoto map with the topographic map. We're going to look at oblique and vertical aerial photos, where you need to be able to identify landforms and features. Also the use of size, shape, tone, textures, shadows and patterns to identify certain features, landforms and activities on an aerial photo and the orthophoto map. And then as well as some orientation of orthophoto maps with topographic maps. So let's start off with the theory. You need to define, identify and apply the following concepts: a stream order, the river discharge, laminar flow, turbulent flow, a river profile, of which cross or transverse profile is one of them, and the longitudinal profile. Now, boys and girls, all these terms, you need to know the concept so that you can be able to define each one of them. You need to be able to identify the concept in a source or on a topographic map. And then they might ask you an application question. For example, determine the stream order. In any case, in a map, a topographic map, or on a source. Okay, let's start with stream orders. Remember the previous slide we said, this is one of the concepts you need to know. You must be able to define a stream order, to identify and to apply. Now, what is a stream order? It is the number, you'll see later on, it's a number like 1, 2, 3, 4, given to a segment of a river. Another word for a segment is a part of the river, to indicate the interconnectedness of tributaries in river systems. Remember 2 weeks ago we spoke about specifically a tributary. A tributary is the smallest, a very small river that's flowing into a bigger river. So we're going to look at the part of the river that shows us interconnectedness is where they come together, where they flow together. So where your tributaries flows into a bigger river or stream. But its stream orders are always numbers. Now you will see here we're using a ranking system for this. Now if you look there, your first order streams has no tributaries. Now if you look at this diagram, you will see the smallest rivers. Look at the light colors. The smallest parts of the river is, we say, first order stream. There's my first order stream. It's the smallest river. The smallest part of the river. There's no tributaries. That's exactly that point where the river literally stops. Now I want to show you also this part of the topographic map, because they can easily ask a question like this. They can even ask you stream orders in Mapwork. So look there, the smallest part is the 1. So I first try to find where does the river has got its origin. There's 1. The smallest part, 1. There where it starts. Okay, so that is our first order streams. A second order stream is when 2 first order streams join. Now look here. 1, 2. 1, 2. 1, 2. There's my 1. Again, a 1 flow. Okay, I don't want to go further on first. 1, 2. 1, 2. So 2 first order streams interconnect and it will form a second order stream. A third order stream is when 2 second order streams join, interconnect. Now look here. So I have a 1 and a 1 is a 2. A 1 and a 1 is a 2. A 2 and a 2 flows into a 3. I can also have it, that's why you start at the smallest part. 1, 2, there's 2, 1, 2. That means from there on, I have a third order stream. Now you'll see I can even have a 1 that flows into a third, but the smallest is 1. 2 ones flows into a second order stream and 2 second orders flows into a third order stream. Look here. 1, 2. 1, 2. A 2 and a 2 will form a 3. So there at that circle I will have a third order stream. Now if I have my map like that, there you can see it. I just want to go back. Your first orders and then your second orders. Now what is the relationship between stream order and the factors that influence it? The lower the order, the greater the number of segments. The lower the order, the greater the number. The more I have smaller segments, the more I have tributaries. The lower the order, the shorter the streams. Now I want you to look at that diagram. Look how short these small 1 order streams are. Lower the order, the shorter the length of the stream. The lower the order, the steeper the gradient. Remember, where does a river start? It starts high up in the mountains. So the lower the order, the steeper the gradient. The lower the order, the greater the total length of the segments. The lower the order, the greater the total length of the segments. And that means the segments will be longer. You can see here I've got a longer one. There we have a longer one. So there we also have a longer one. The greater the total length of everything is going to be. As I said, This is a very, very good question that I can ask in a Mapwork application. So here you can see, there's my first order, and I have second order there. There's my first order. Here again, I have a first order, they meet there, they flow into a second. The moment that I have a second and a second, I have a 3 order. There again, 1, 1, 2, 1, 1, 2. And then that one flows in there. So here I have a 2 and a 2, a 3. A 2, there's the 2, there's a 2, it flows into a 3. A 3 and a 3 flows into a 4. What is the trick here? You start always at the smallest stream, the smaller length of a river. Now, boys and girls, here's worksheet 1. The way that I can ask you is, for example, to determine the stream order at point X. And then this is the application question. Why will the stream order be higher at point Y? Here's Y in diagram A, and here is X in diagram B. I'm going to give you 2 minutes to complete this activity. Okay, boys and girls, I'm just going to check this one for you. So if that's going to be a 1, and the 1 is going to be a 2. That's also the smaller one, so it's going to be a 1. You make it physically, you mark it like this. So I have a 2. Still a 1, still a 1. So this one is going to go in this. So I assume the answer must be 2. Let's see what the answer is. Stream order at point X is second order. There you can see how it was determined, as I said. Now question 2 was, why will the stream order be higher at point Y? Now there's point Y, and if you look at that, by the way, look at the drainage density. I can combine a question on drainage density with this one. Oh, I see a lot of streams there's a lot of first order, second order, and third order streams. There are more fingertip streams which increases the drainage density further downstream. So that can be, sorry, I was very quick here. there are more fingertip streams which join, increasing the drainage density further downstream. So you can also say there are many first order and third order streams. Remember, the more tributaries there are, the thicker or the wider this line will be thicker, the river will be wider, because there are lots of smaller rivers that flows into the river at Y. What is discharge of the river? Remember I said to you it's a concept and you need to know the concept. It is the amount of flow in a river passing at a specific point at a certain time. The amount of flow in a river passing at a specific point. How do we measure this amount? We use cubic meters per second. The discharge of a river is illustrated on a flood regime for a year and on a flow hydrograph for shorter periods of time. So it's the amount of water basically that flows at a specific point at a specific time, and it's measured in cubic meters. Now, boys and girls, we come now to types of flow. Listen what I'm saying? Types of flow. So the first one that we get is laminar flow. Laminar flow. What is laminar flow? My riverbed, where's the riverbed? If this is my river cross section, there's the riverbed. The bottom of the river, that bed is level and even. That means there's absolutely no obstacles in that specific river. The riverbed is level, it's flat and even. The river normally flows here at a high speed, but there's less erosion. High speed, less erosion. The water basically flow in layers. It looks as if it's layer by layer that this water is flowing. The water that is in contact with the bed and the banks slows down due to friction. So at the bed and on the banks, the water that is there and there will be direct contact, there will be friction, so obviously the river there will flow much slower. The greatest speed of the river, however, is there in the middle of the river. In the middle, just below the surface, there's the surface. So in that area there in the middle is where the river flows fast. If I can give you a picture or a photo, this is how the laminar flow in a river looks like. It's parallel sheets. It's an uneven riverbed. Remember, you need to be able to describe. There's less erosion, and then the only erosion basically we will have on the sides or down there at the bottom of the river. So these three things are the characteristics of laminar flow. So now you can define it, and you can identify it, and you can list the characteristics. A turbulent flow, you see, your arrows is very, very demarcated. It's flowing up and down and left and right. So this type of flow is turbulent flow. Why? The riverbed is uneven and it's normally associated with the area that's very steep. So it's a steep area where we have an uneven riverbed, which means there's most probably some obstacles in the river on the bed. The river continually changes levels. That means then is high, it becomes lower continuously. The level, how high the river is, normally changes. And this water has got this bubbling action. You can hear water is running in that specific area. The water flows slower, but it has got more erosion because the riverbed is uneven. There is more erosion because of an uneven riverbed. And there's a nice photo for you, and there you can see the bubbling action. There's turbulence, né? The riverbed is uneven. I have more erosion in this case. Let's show you a video.
And when we have a look at the discharge of a river, it's very important that you must have a look at two types of discharge. We've got laminar flow on the one side and turbulent flow on the other side. Now, what you must know is you must know the difference between your laminar flow and your turbulent flow. And you must know why do we get it and the process that the processes that we get in these type of flows. Now, let me just get this thing started here. So if you have a look at this, people, then immediately you will see that on the one side, we've got the water flows as parallel sheets. Have a look at that. Beautiful parallel sheets. But look at this. Very turbulent, the water is flowing on the side. Why is it flowing parallel sheets? Because the river bed right at the bottom will be even. Now, if you look at this one, immediately you must know that the river bed on this side will be uneven. And of course, just look at the way the two of these rivers flow. Of course, there will be more erosion on this side by your turbulent flow than in your laminar flow. So people, please, you must know the difference between laminar flow and turbulent flow. Now, last year in the exams, they asked a question with regard to laminar and turbulent flow, which I would like to share with you. It was a more short type of question. Now, people, I would like to tell that just as in our previous ones, as soon as you see this icon, you must know we're busy with an exam question. Right, now, the question was as follows. Study the figure below. Indicate whether each of the following statements refer to turbulent or laminar flow in a river. Now, here we've got the diagram. And here we can see our turbulent flow there, and here we can see the laminar flow here. And I hope you've made a mental note of the images that you've seen in the previous slides. I purposely put the two next to each other so that you can see the difference between the two. Now, all you had to do in this question is they made a few statements on this side, and all you had to say is it laminar or is it turbulent? It's as easy as that. Have a look at that. Associated with the riverbeds that's level and even, of course, then it would be laminar if you've listened to our discussion. Okay, associated with irregular swirling flow, the turbulent flow, turbulent. Well, look, so easy is this. Effective in eroding, of course it will be turbulent. Commonly occurs in the upper course of the river. We're coming back to the upper course, just hang on with that so long. That will be turbulent. The water flows in thin layers. Remember the video clip that we showed you. Laminar, associated with higher river velocity, which also be laminar. Occurs where rapids are visible in the river's course. Of course, that will be turbulent.
Okay, thank you, boys and girls. There you saw a video on exactly how this looks in reality. Okay, worksheet 2, laminar and turbulent flow. There's our question. Refer to figure 2.2 showing laminar and turbulent flow of water in a river. Match the descriptions below with either A or B. Write only the letter. You can see the A is laminar, B is turbulent, and write only the letter A or B. So there are your options. I'm going to give you 2 minutes to read through each one and to choose between A or B. And girls, let's quickly look at the answers that we have here. The rapids are characteristic of this type of flow. It is B. Rapids are like small waterfalls. Ne? Rapids are characteristics. It's associated with an increased volume of water in the lower course. If I look at this, the lower course is where the river is, close to the sea. So it's going to be A. Associated with a higher rate of erosion, B, because there's lots of turbulence. Ne? It occurs mostly in the upper course of the river, it's B. It promotes the formation of floodplains and levees, A level riverbed which causes water to move in layers, it's A. And the surface friction causes water to form swirls, it's going to be B. Boys and girls, the fluvial processes. Oh, I just want to go back. Mrs. Cynthia Zondi is going to take over from me now. We're just giving you a 2-minute break. Mrs. Zondi is going to take over and she's going to take you through the fluvial processes. Goodbye, see you next week. Don't go away, Miss Zondi is going to take over now.
Boys and girls, I am now going to continue with today's lesson. My name is Cynthia Zondi. We are now going to look at the fluvial processes. Okay, so remember when we indicated our lesson objective, it is important that you know the concepts. So part of what you need to understand and note when you get to these fluvial processes, there are concepts that you need to put into your head, okay? With the fluvial processes, we're looking at the physical interaction of flowing water and the natural channels of rivers and streams. So basically, when we're looking at the fluvial process, we're looking at the physical interaction. Physical in a sense of a natural interaction of the water that is flowing in our rivers, and also the channels over which the river is, the channel of the river, as well as the streams. So primarily what shapes the channels of the river would be your vertical erosion, that we are also going to look at how it is responsible as one of the processes that are responsible for shaping our river channel. Okay, and then we also have to note that within the river channels there are large boulders, which is your large rocks that we can find, and these would be deposited, and some of these boulders would be eroded. So the size and the amount of water that would be flowing in the river would determine if that particular boulder can be transported further or it would be laid to rest. So we would have deposition taking place if the capacity of the river cannot be able to transport the water. And then also this large boulders would be broken down. They would not remain in its natural sizes. So there will be some erosion that will take place. And then also this erosion, it continues to cut the river vertically, but it also begins to cut laterally. So the type of erosion process that we will experience is that the river would be cut vertically, meaning that it would be increasing the depth of the river, and then also it would cut the river laterally, which then increases the width of the river as it gets closer to the lowest point. So all this is dependent on which part of the river that we are referring to. So as it gets closer to the lowest points of the river, we will now observe that the river is no more narrow as it was at in the upper course, but now it starts to widen as it gets into its middle course and towards the lower course. Okay, the other process that we also should take note of this, which is taking place, there would be deposition that will occur in the slower moving inside of the meander. So as the river meanders, some processes that would also take place would be deposition. And then when the river now starts to flow slower, that's when we are going to experience more of deposition taking place. And on a river meander, it would erode on the outer bend, but on the inner bend of the meander, that's where we will experience deposition taking place. Okay, so these are fluvial processes that are responsible for shaping the flow, the river rather. We are looking at erosion process. So it is the process in which materials are removed by an agent. So an agent can be water in this case, because we're talking fluvial, which refers to the river. Okay, so the process whereby material is moved or it's removed from its surface with the by water, that would be due to the process of erosion. And then the other processes that we are referring to here that are responsible for these fluvial processes, it's transportation. So here now we've got transportation of the eroded material. So it is the process in which the eroded material is carried away. So we said that there would be cutting in, vertical cutting, and there would also be lateral cutting. So the smaller rocks that are broken down there will then be transported by water that is flowing in a river. And then that's where now we talk about a transportation process. And then we also mentioned that within these fluvial interactives that we have here, there will be deposition that will take place. So here now it is the process in which material is dumped, or we can say it's laid down. So all the eroded material that is carried by the water there, that is transported. Some of it would be too heavy for the river to carry it through, and then it will be deposited. And then the other thing that would determine the deposition, it's where now the river starts to flow slower, and then it will then lay down, or it will dump some of the material that it was carrying with it. Right, okay, we are now looking at the longitudinal profile of a river, of which all the processes that I mentioned in the previous slide, we are going to see them throughout the river in its longitudinal profile. So what is longitudinal profile? It is the side view of a river from the source to the mouth. So when we look at the river from the source to the mouth, it will give us that concave shape, which determines the profile that we are looking at, that is a longitudinal profile. So the shape would be concave. And then the other thing that we observe on a longitudinal profile is that the river is steep at the source, and it gets gentle as it moves towards the mouth. So where the river starts to flow, it would be steeper, and then it would get into a gentle slope as it flows towards the mouth, which is the sea. Okay, so this is just an illustration of when we're talking about longitudinal profile of a river. So we are looking at the river from the source to the mouth. And then what shape are we getting? We're getting these concave shapes. So this is all what we're referring to when we say it is concave in shape. And then when you look at the angle of the surface here, it is a steeper surface. And then as you move away from the source towards the mouth, then the gradient is changing, and then the river starts to flow on a gentle slope. So this is what I was explaining in this. Okay, so here we can identify this is the source, because the river would be flowing from the top of the mountain down the top of the mountain. So the source of the river would be at the top of the mountain there. And then when we now identify the mouth where the river flows into, it could be flowing into the sea. So the sea would be the mouth of the river. So water is poured out into the sea there. So we can identify the mouth there. Okay, when we identify the river course now, so at the where the river starts, we identify it as the upper course. And then continuously, as the river continues to flow and the gradient is starting to change, then we can see now the river is in its middle course. And then right through now where the river is heading towards the mouth, we then can identify the lower course. So these are the three river course profiles that we can identify in a river, within the upper course, the middle course, and the lower course. Okay, so take note of what is key here. The source, it's what you need to know, and the mouth, and then the shape in which we can identify the longitudinal profile, and then also you need to take note of the gradient of the river from where it starts to where it is flowing. All right. Then we are now looking at the other form of a river profile, which we are now looking at the cross profile, or what we refer to as the transverse profile. So what do we mean by cross profile or transverse profile? This is where now we are looking at the front view of the river. So it's as if you are standing in front of the river. So we're viewing the river from the front. And then it shows the cross view of a river from bank to bank. So as you can see, this would be bank 1, and then bank 2, and then we're looking at the third river bank. Okay, so it shows the cross view of a river from bank to bank. Okay, and then can view the width and the height. So when we look at the cross profile of a river here, when you look at this profile, for instance, here, we can see how wide the river is from the shape that we can identify here, that we can see that, okay, the shape here looks more narrower. So the valley, it's very narrow there, okay? And then we can also identify the height from our profile here. We can also see the height of the river valley there. So we're looking at, we can that's where we are able to draw differentiation in terms of these cross profiles. When you look at the width, you must see the difference, as well as the height of the river profile there. Okay, so still here, that's what we can identify. As I've indicated, it's as if you're standing in front of the river. So when you're viewing it as if you're standing here. The river is flowing from that direction, in that direction, and you are viewing the river from the front of it. So from this, we can see there's the valley that is very narrow at this point. Okay, then relatively to that, we are now looking at the mature stage of the river. And take note of the stages here. Where the river is at its upper course, we refer to it as the young stage. And then in its middle course, we refer to it as a mature stage. And towards the lower course, we refer to the stage as old. Right, so here we're looking at the cross profile of a river in the middle course. So notice the difference in terms of the size of the width that I have indicated to you there. That now the width it's getting, it's opening up. And then also when you look at the height, remember the erosion processes that took place now has resulted in the height of to be reduced there. So there's more erosion that has taken place. Initially, this was the elevation of the valley there. But then now the valley has just gone through the process of erosion, and there has been lateral erosion, as I have indicated there, that what would determine the size would be, the shape of the valley would be either the process of vertical erosion, where the river is cutting deep into the valley. And then here now what we can observe is that the river is eroding even onto the side. Hence, we can observe that the valley is becoming wider there. Okay, then when we look at the lower course of the river, it's even flattened. The river valley there, it looks more flattened, and its width has also extended further due to the process of lateral erosion that was taking place. So this is what we can see. This would be a U-shaped, and this would be a wider shape from what it was in the middle course. Okay, so the thing that you need to note, it's The type of erosion that is responsible for shaping the valley into its narrow V shape, which is the downward erosion or vertical erosion. And then also what we need to observe about the mature stage, what the type of erosion that we can identify here, it's the lateral erosion. Okay. And then within the old stage of the river, so with the width of the river that has extended to this size, we now don't have erosion taking place more, but we have more deposition that is taking place. Mind you, the river now is flowing on a gentle slope, as you can observe from here now that the slope is now over a gentle area. Okay, so this is just an emphasis on what characterizes each of the river course. So in the upper course, we have mentioned that there is vertical erosion, which depends the valley. So from this picture, you can see that we've got that narrow V shape that you can see from here. Okay, then what else do you need to take note? Straight stream channel with short non-perennial streams. Okay, so what the type of streams that we can identify there in the upper course would be your non-perennial streams. Remember, this is where the river starts to flow, so there isn't much of water that would be added into the streams. So the streams would be more of non-perennial because it may only be dependent on the amount of rainfall. So there's no high volumes of water there. And then also what we can identify there, there's a straight stream channel, which we will draw the distinction when we look at the river as it progresses into the middle course as well as the lower course. The type of flow that is taking place, as my colleague Rina has alluded to this point, would be turbulent flow. So we in the previous presenter, you drew the distinction between what a turbulent flow is. So turbulent flow due to uneven riverbed. So the riverbed is uneven, so it's more rocky. So, and therefore the flow then becomes turbulent. And also it's because of the valley slope, which is more steeper there. Okay. Then the type of landforms that we can identify, mostly we would identify your areas of the waterfalls as well as rapids that are being eroded through headward erosion. So either than just the vertical erosion that I have spoken about, which cuts the valley into a deep, narrow valley, we have the river eroding backwards towards its source. And when it erodes backwards towards its source, that type of erosion, we refer to it as headward erosion. So it's eroding backward towards its head where it starts to flow. So the two erosion processes that is taking place, it's not only deep down into the valley, but also we have a river cutting backwards towards the mountain. So towards the mountain range that the river is coming from. There's large stream load with big boulders. So there's big rocks that would be found in there. So the stream, there's a large stream load. So the load of rocks that falls off from the mountain would be found at the upper course of the river there. So those big boulders would be identified there. And then also there is a traction load, which is also due to the erosion that has taken place. There's more of cutting of the rocks on that surface. Okay, then let's look at how then we link or we integrate this content that we have been discussing with our Mapwork section. Okay, so here we've got a diagram that is indicating the topographic map. So what we can see on this topographic map, we can see this is a Meiring Ridge peak. So From looking at the contour lines that we can identify here, it shows that this whole area is over a mountain range. So there is a mountain range over which the river is flowing from. Okay, this is the river. We can identify the river there. And what we can identify are the tributaries that are joining this particular river from either side. So hence I said, take note of the name that is indicated there. It's a ridge, so it's a long stretching mountain there. Right, so we are looking at the upper course, where now we're saying the river has that V shape. Okay, so what characterizes the upper course? As I've mentioned, I said the river is flowing over a steeper gradient. So from the mountains, if we are looking at the main stream here, the main stream that we are looking at, what do we identify? We can see that here there is a set of contour lines that are showing a surface that is more steeper. So as you observe, then you should be able to draw the distinction into which side of the map is the river flowing from. So looking at the pattern of the contour lines in all this area, you can see that the contour lines here are close to each other, and then they would get more space as it moves in that direction. All right. And then the other thing that would help you to determine in which this river is flowing, it's the angle at which the tributaries are joining the mainstream. So that's what will also show you in which direction this river is flowing. So when you look at all these tributaries, they are pointing in one direction, meaning that this river is flowing in that direction. So this river is flowing over a steeper gradient, and even from the tributaries that are joining this mainstream, we can see that the angle that it's, the gradient of this area, it's from a steeper gradient to a gentle gradient there. Then what we find there is that obviously, because the gradient is steep, streams would be flowing in a faster speed. And then the type of erosion I have mentioned, we said we experience downward erosion as well as the headward erosion. And the type of landforms that we can identify, it would be either the landform such as waterfalls or the rapids. And what else that we need to take note here? It's the interlocking space. So the interlocking space, remember, we find them, these would be your areas that we can identify the space over which the tributaries are showing there. Okay, so we have an interfluff, which would be the land that we find in between, and then we can also find a set of interlocking space that we can identify from the landscape that is shown by this set of the contour lines rather. So that's what characterizes the upper course. So all these are important to note when you interact with your map work as well. All right, let's look at the middle course. The middle course, we have vertical erosion that decreases, and now we've got lateral erosion that dominates. Remember, we said now the river starts to get wider as you can see from there. So there is lateral erosion. So the river has moved from being a vertical shape into a U shape, and then the channel becomes wider. Then the other thing that we can also notice, the river starts to meander. So there is that winding pattern of the streams due to lateral erosion. So as the river is flowing, it would come across a hard rock surface, and then it would wind and find its channel onto the softer rock there. Then tributaries join the mainstream, increasing the volume of the water. Remember, we said in the upper course there's less volume of water, but then now what increases the volume of water is because there's more tributaries that are joining and also the river becomes more erosive rather, because there's the volume of water has increased there. Then both laminar and turbulent flow occurs depending on the roughness of the riverbed. So some part of the river in this river course would be flowing over a surface that has got the even riverbed. But where now the riverbed is uneven, that's where we're going to experience the roughness, and we can then identify a turbulent flow. Okay, then the other thing that we should also take note, there is saltation of load that occurs here. So there is more of the agents of erosion that would flow into the particular river will then result in the saltation of the load there. So that characterizes the load that is carried or that is transported though. Then the load becomes smaller due to attrition. So the bumping and the grinding of the rocks there would result into the load being smaller. So all these boulders of the rocks that I indicated that they would characterize the upper course. So as we have the erosion that is taking place, some of the boulders would then be reduced due to the processes of attrition and abrasion. As rocks bump and rub against each other, they then change the size and then they become smaller. Okay. Then what we want to show here, it is the middle course. So when you compare the two map clips here, we can identify now that this river, although it's a different river, so here now we're looking at a different river, but what do we want to show you? That the river now is flowing over a gradual slope. You saw the pattern of the contour lines in the previous slide. There were too many contour lines that were indicating that the slope there is steep. Here now there's minimal or there's less contour lines. That shows that the surface is becoming gradual, and also the spacing between the contour lines, as you can identify here, the spacing now indicates that the gradient here is gentle because the contour lines are now further apart. Okay, so the water starts to flow in a slower motion, and the erosion process that is dominant, we said it's a lateral erosion, and we said the vertical erosion, it's now slowed down. And then the type of landforms that we can identify is that we can identify the meanders. So as you can see, even from this, the river is meandering. So there is some winding pattern of the river here. Okay, so the slope, you have to look at your contour lines for you to be able to know which river course are you referring to. So your contour lines will tell you whether the slope here is steep or gentle. And then also, obviously, when you are able to identify the type of a slope, then you know the river will not start to flow slower. And then also there will be the expansion of the width of the river, and it becomes more flowing on a gradual slope there. Then we look at the lower course. Here, the processes or the fluvial processes that we referred to right at the beginning, what dominates now is deposition, where there's now very little erosion that is taking place. The channel is at its widest. So comparatively, when you look at the river channel here, it is more wider than when we looked at the first diagram. And then the other thing that we can also identify is that there is extensive meandering. Remember, we said in the middle course, there would be development of the meanders. But now here, the river starts to meander extensively due to the flat surface and due to lateral movement of the river there. So we cannot rule out meandering taking place in the middle course. But here now, the comparison that we're bringing in is that it becomes more extensive. Then the river discharge type of a flow, there we're saying we can identify that there is laminar flow which dominates due to the smooth riverbed. And the sides of the river there are the ones that are influencing the laminar flow there. So there's the river is flowing over a smoother riverbed. Then we've got processes that are taking place there, which is suspension, meaning that some of the finer particles would then be laid down, and there would also be a solution of some of the particles that is carried along there. So it would form, the water would be a bit murky there, okay? So that indicates the processes that take place in the lower course, right? Then the last point to note there's very large load but smaller particles. So there's a large load of material being deposited there. But when you look at the size of the particles now, it becomes finer and smaller particles that you can identify there. Hence, we talk about solution. All right, then we're looking at the lower course over a topographic map there. Okay, so as I have indicated, when you look at this river, for instance, can you see now how the meandering is becoming more extensive, unlike the previous slide where we just saw that, okay, there was meanders, but here now we can identify that extensive meandering that that takes place at this stage. And then the characteristics would still be, as I have indicated, the river is flowing over a gentle slope, and all these are the landforms that we can identify. Okay, there's a meander that we can identify, and then there's a floodplain, which it indicates that the flat land over which we can identify alongside the river there. And we can also identify the meshes and flay there, and the development of braided streams. So there's an interlocking of streams there within this lower course, which we refer to them as the braided stream. And we are going to further explain on each and every one of these fluvial landforms that you can identify here on how they are develop. But for this lesson, we'll just identify them like that, right? Boys and girls, we've got this worksheet that I have that I want you to work on it. Figure 1.6 shows the changing cross profile of the river along the river course. So as you can see, there's the upper course, the middle course, and the lower course, right? Here's your question. In which course is the river source of the river? And then the second question, name two elements of the cross profile that changed from the upper to the lower course in figure 1.6. Third question, differentiate between the fluvial processes that shape the cross profile of the upper course and the lower course of the river, for 4 marks there. Describe the reasons for the change in the shape of the cross profile of the middle course. That would be for 4 marks. Okay. The last question, explain why the shape of the cross profile in the upper course of the river will make it the most suitable place to build a dam. All right. Just to put emphasis on your question verbs or verbs that have been indicated here, so that you make sure that you answer your questions according to the expectation. There's explanation of differentiate here. You show the difference between two things. So in this case, you look showing the difference between the fluvial processes that shape the cross profile of the upper course and the lower course. So you're looking at both the upper course and the lower course. Then the next question, describe. What does describe mean? It means that you list the main characteristic of something. So you're giving a clear description of something. So here we're giving a description of the reasons for the change in the shape of the cross profile. We can see there's a change here and there and there. So give reasons for the change in the profile of the middle course rather. So your focus will be on this one. Explain why the shape of the cross profile in the upper course of the river. So when you explain, you have to make it clear, make your point very clear. You interpret or you spell out why the shape of the cross profile in the upper course of the river will make the most suitable place to build a dam. Right, you are going to take a screenshot of this question and then see how far you can go with the 2 minutes that I'm going to give to you, and then we will look at the answers. Your 2 minutes will start now. Okay, boys and girls, let's look at the answers to these questions. Right, you've got your 3 cross profiles there, your upper course, middle course, and the lower course. All right. Then in which course is the source of the river? So for 1 mark, the answer is the upper course. Okay, we have explained that. Name 2 elements of the cross profile that changed from the upper course to the lower course. 2 elements. So you have to name 2 things that have changed from the upper course to the lower course. Right. Your expected answer, it's the width or the breadth and also the depth of the river. Okay. So when you look at this, initially the river was at 300 meters high, and then the dimension was 2 kilometers. So the height, you can see that the depth of the river has changed from this, and then also we can also see also the how wide the river was, it has changed, and how deep it was, it has also changed. So we can see that it's no more as deep as it was between the 3 stages. So it has become more wider, but it has the depth has reduced to 100. So you have to take note of these figures, as they are the ones that are guiding you in terms of why the answer is the width and the depth that we are looking as the factors. And then also the shape, you can also see that it's normal that sharp V, it became a little bit wider and became more flatter. All right, so the shape also has changed. The height of the interflows also have changed. So when we're looking at the interflows, would be this part where we're looking at. So the height has changed of the interflow from this point to that other point there. Then those are the answers for those questions. Then we look at the third question: differentiate between the fluvial processes that shaped the cross profile of the upper course and the lower course. So what do? We are expected to differentiate. What are we looking at? The fluvial processes which shaped the cross profile. The comparison that we are doing is between the upper course and the lower course. All right, so here is the difference. In the upper course, the vertical or the downward erosion takes place. So here's the fluvial processes that we are talking about. What is this? The vertical or the downward erosion. So we are saying in the upper course, the vertical erosion takes place. And then what other difference are we then going to look at? What is then happening in the lower course? Remember, your key question areas is the upper course and the lower course. Then in the lower course, what difference of the fluvial process can you take note of? In the lower course, there's deposition or lateral erosion that is taking place. So this is something that you also do in the exam so that you don't miss the point of why you should get this 4 marks. You must look at what are you supposed to do? You are going to differentiate. And then what exactly are you differentiating? You are differentiating the fluvial processes between what? Between the upper course and the lower course. So you must then give a fact about each of those. Then we look at the next question. Describe the reasons for the change in the shape of the cross profile of the middle course. So you're giving now a description for the reasons for change. So why has the shape changed in the middle course? All right. There's increased lateral erosion, or you can say decreased downward erosion results in the river valley widening. So that is the reason number 1. Then the other reason, the description that we are giving, the sheet flow down the valley slopes will result in the lowering of the slope. So that is also what resulted in that change of the shape. River slows down in the middle course, causing deposition which decreases the depth of the valley. So the material that is deposited here, some of it would then make the river to be not to be as deep as it was, and also to change its shape from being this sharp to becoming this wider now. Then the other answer that we can look at, the gentle gradient in the middle course causing deposition. So the main process that we are looking at now is that the river is flowing slow, there is deposition. There's a sheet flow down the valley, which results in the lowering of slope. So there should be the cause and the effect. So this would result in that. You must also be able to answer it like that, even in the exam, if you come across a question like this. So there's a gentle gradient in the middle course, which causes deposition. So this is one of the things that you should be able to do in case you come across such a question. Right. Meandering river will widen the valley floor. So there should be the cause and the effect. So here the river is meandering. So what does it do? It then widens the valley floor. Where the river exits the confines of the mountain, the river valley will be wider. So when the river exits the confines of the mountain, then it becomes wider. Isn't it that the mountains were just restricting its width. So because now it has left the confinement or being between the mountains, then the river then becomes wider as it leaves the confinement of the mountain. Greater volume of water and lower velocity will increase lateral erosion. So there is more lateral erosion because of the greater volume of water and also the lower velocity. So those are your answers. And then let's look at the last question. Explain why the shape of the cross profile in the upper course of the river make it the most suitable place to build a dam. The shape of the cross profile in the upper course. Why is it the exact place where it's most likely to build a dam? In the upper course of the river, the valley is narrow. So that is the other fact that we're considering. The cost of construction on the dam wall will be cheaper. All right. And then the rocky banks will make the structure stronger. So all these are the facts that makes the upper course to be ideal place or suitable place to build the dam. Then the dam will be deeper because of the deep valley. All right. Cooler temperatures at higher altitudes, therefore there will be less evaporation. Remember, it would then sustain the water, so there would be no too much or the high percentages of evaporation, which would reduce the amount of water. Smaller water surface area reduces evaporation. So water would be confined into a smaller water surface area, which then reduces the evaporation rate. A deeper dam rather, will have an increased capacity. Okay, so less silt in the dam as there are fewer tributaries. Remember, we said there's fewer tributaries in the upper course, so there is less of silt, which is your smallest minute particles that we can find in the water. So that would make the river to have more capacity. Steepness of the valley or steepness of the slope allows easy flow of water into the dam. So water can be flowing swiftly into the dam due to the slope. Right, we are now going to look at, we're crossing over to the Mapwork section, which you got an indication of as part of what you were doing in this week. All right, we are just going to look at the difference between how a topographic map and how a orthophoto map looks like. So all of you now, you should be able to identify your maps. So this is a topographic map, and this is an orthophoto map. And then the use of the color would also help you to identify as to which is which. And then the other thing that you must also take note is the scale that we can identify, which is different between a topographic map and an orthophoto map. So the scale of a topographic map is 1:50,000. And then the scale of the topographic map, generally with the maps that we are using, is 1:10,000. So this is the difference that we need to note into how each of those maps look like. Okay, so with what is it that we find between the maps that I have indicated to you? So we can identify that we can find the natural features. So when we look at a topographic map, how do natural features look like, or what are we referring to basically? It's any feature that appears naturally. And then what examples are we talking about? The ocean, if you can identify a map that has natural bays, the shores, those are the natural features. The island would be one. The river, the lakes, as well as the dams that are natural. We can also identify the bushes, the vegetation, as well as the forest. Okay, so all these are what we refer to the natural features that we can identify on a map. And how do we then identify this? What is represented on a map in blue, as you can see here, you can see there's that blue line that we can identify. There's another blue line that we can identify here. So what we use that color to identify would be your water resources. Okay. And then what is it that we also use in the topographic map? We would find the brown lines that we can find on the map. And then these brown lines would be representing the contour lines. So all these contour lines that we can see here, it's the identification of a natural feature. Remember, the elevation of the land, the landscape would be in natural. So those are the examples of the natural. And then on maps, we have what we identify as the constructed or the man-made features. So constructed features or man-made features are any features that or any feature that is constructed on natural areas. So it's something that is man-made. And then what examples are we referring to? We're referring to transport and infrastructure. We're referring to the dam walls. Remember now, not all dams, as I have mentioned in that other slide, would be natural. Some would be man-made. And then we're talking cultivated land or the water purification plants. Buildings are examples of all the man-made and artificial features. And that is all what we are referring to when you talk about man-made features. So how then do we identify these on a topographic map? Represented as black and gray lines would be your gray areas and the black symbols. What we can see here, can you see there's black features that we can identify here? So this would be your man-made. What you can also see here, these examples are the man-made according to the color code that we are referring to. So the black and the gray lines, as well as the gray areas and the black symbols. Okay, so green areas would indicate man-made features such as the cultivated lands. So it would be cultivated lands that we can identify here, and you can also identify the orchards and the vineyards. So all these green symbols that you have according to your conventional symbols. So the green areas that you can identify there. The other thing, blue lines that indicate canals or the blue symbols, as well as the use of the red lines here. So on this map clip, I don't have the example of a canal, but what we can identify as a man-made feature which relates to the red would be this particular road that we can see there. Okay, so that is just a summary of what are the artificial features. Then we are going to look at aerial photographs. So remember, we were looking at the topographic map and the orthophoto map. The other thing that you also need to have an understanding of is an aerial photograph, as well as how it's used up to develop maps. So the information that we find on the aerial photograph, we can identify the type of a landform that we can see on that photo, the relief of the landform. Remember your contour lines if we are talking your orthophoto map as well as your topographic map. And then also, what else can we identify on these maps and photos? Drainage patterns. We were discussing drainage patterns in our previous lesson, and we also used some map clips to show how you can identify it, even with the maps that I was using now. So we can be able to identify the drainage patterns there. Then also with the drainage density, when we look at the amount of, or the number of streams that we can identify within a drainage basin, and we can also look at the drainage distribution. The other information that we can use and find in the aerial photographs is to describe the settlement, although we are not yet into the topic of settlement geography, but you need to know then that these maps are not things that you would just use for your Mapwork section. But when we discuss topics such as settlements, where we're looking at the difference between the rural and the urban settlements, you should also be able to use the maps as well. Describing the settlement, if it's mutilated or the dispersed, we can also use our maps to describe that. Describing the concepts such as what is site and situation of a settlement. So all these would be part of the topics that you are going to discuss in term 2 when you're now doing settlement geography, when you're done with your geomorphology. So that is the link that we want to bring there. Indicate what the land is being used for, so all that it's still part of your settlement, or even the other economic activities that we can identify what the land is used for. Types of aerial photographs. So we are now looking at the different types of the aerial photograph. We have number 1, the vertical aerial photograph, and we also have an oblique aerial photograph, and we also are going to look at the horizontal photographs. So let's look at the difference between these 3 aerial photographs. So a vertical aerial photograph is a photo that is taken from an airplane which is flying directly over the landscape. So when you look at this illustration, this would be the film of the airplane that is flying over here. I mean, of the camera that is embedded on an airplane. And as you can see, the photo is taken directly into this particular area. So that is the whole area that is covered by the camera lens that is attached onto an airplane there. Then photo is taken at 90-degree angle. So if you look at the angle here that we are referring to, it would give us that 90-degree angle if we look at from there. Then the other thing that you also need to note shows the top view of the landscape. So remember, the airplane would be flowing directly on top of the area that is captured. So then the picture or the photo would be showing the top view of the landscape, and also the scale would be bigger. Usually printed in black and white to save costs. So you may find some of the aerial photographs that are in color, but if they have to produce that particular aerial photograph in bulk, then it would be in black and white. It helps us to map the large areas that are inaccessible. So you can just imagine, boys and girls, that if we were to want to map an area of Johannesburg, the only way in which it can be easier is when we take an aerial photograph, because you cannot do it whilst you are on the flat surface. Okay, and also it helps us to get pictures or the photos of areas that are inaccessible. Then this is just an example of an aerial photograph that is taken with an airplane that is focusing exactly directly onto the area that it is targeted at. So this is just an illustration of an airplane, and there's the part where the camera is attached onto the airplane, and these are all the areas that are captured as the airplane is moving. All right, and we can see from that picture that it shows the top view. Right, we then look at the oblique aerial photograph, that which is the photograph that is taken from high above the ground at an angle of non-vertical to the ground. Remember the other one, it was vertical. So this one is non-vertical to the ground. That's an oblique aerial photograph. And we've got two types of oblique aerial photograph. That's one thing that you also need to note, that with the oblique, we've got two types. We've got the high oblique as well as the low oblique aerial photograph. We are going to look at the difference between the two. Okay, there's the illustration of the oblique. So you can see now the angle at which the camera is tilted. It shows that the focus of the camera, it's not as vertical as it was, but now the picture is taken at a particular angle. So depending on the angle in which the camera is tilted, it will determine if the horizon would be showing, which then brings the difference between what a high oblique is and what a low oblique is. So part of the horizon may be visible and it may not be visible. But where do we see the difference between these two? The high oblique and the low oblique. So let's look at the difference between the two. When we are looking at a photo that is high oblique, the horizon is now visible on the photo. As you can see here, this is where we are referring to, Uti. We can be able to see the horizon there. And then it shows a bit of an area. So it would cover the smaller area. So we can just see the smaller area that is taken there. Then when we look at a low oblique, the horizon is not visible. So that is key there, which brings in the difference there. When you look at this particular photo, we don't have any horizon that we can identify there. Then the other characteristic is that it shows a specific image of an area. So can you see that instead of having the stretched surface area, now the camera is focusing directly onto this whole area that we can see here. So it shows specific image of an area. Okay. So that is the difference between the high oblique and the low oblique. Then we've got the third example of a horizontal photograph. So this now we said it's a photograph that is taken on the ground level view, and they are taken parallel to the horizon. So that is the difference here. There's the camera, so it's on the ground level. You can see from here that the camera is on the ground level, and the focus is directly towards the object in a horizontal view then, and it's parallel to the horizon. So that is the characteristic of a horizontal. So this is an example of this on a picture. You can see that the camera man, it's directly horizontal to the horizon there, and the camera it's on the ground there. All right, we are going to look at some of the characteristics of the orthophoto map. Shadows. We've got shadows on an orthophoto map. Then these shadows that we can find on an orthophoto map, it's very important that you take note of the importance of this. The direction of the shadow on the orthophoto map can determine the time of the day the photo was taken. So the cast of the shadow there, it can tell you at what time was the photo taken. And then always look for trees or buildings when determining the time. So whenever you come across a question where they're asking you to determine the time, you must look at these objects on the photo that will be able to help you determine the time the photo was taken. The longer the shadow, the earlier it is. So it means that photo was taken early in the AMs. And then the shorter the shadow, then it means the photo was taken in the later hours of the day. Shadows that lie to the southeast means the photo was taken after 12 midday. after. You should take note of the bold in after there, not at 12. Remember, we don't have photos being taken at 12 to avoid not being able to detect the shadow. So it has to be after 12 or it has to be before 12. And then shadows that lies to the southwest means the photo was taken before 12, not at 12 again. So we don't have aerial photographs that are taken at 12 because the shadows would help us to determine the sum of the features on the aerial photograph, which is used to draw a orthophoto map. Okay, these are the features of the orthophoto map. We have an orthophoto map where we look at tone. Tone refers to the relative brightness or color of objects in an image. So when you look at the orthophoto map, you can be able to identify that there's different tones of this gray or the black that you can identify here. So some of the objects would be darker and some would be lighter. And then also when we look at the tone, the features of the orthophoto, we also can identify the pattern. And orderly repetition of similar tones and textures will produce a distinctive and ultimately recognizable pattern. So if you look, for an example, at this section, you can see that you can recognize a pattern here, that these are buildings. When you look at even onto other sections of the map, when you look at these blocks, that's a pattern. It shows you the street pattern in this particular area. Shadows, I have explained, it is also helpful in the interpretation in terms of the cast of the shadow, if it's on the southeast or the southwest. Then lastly, on the slide rather, the shape refers to the general form, structure, or outline of an individual object. So the shape would tell you that this is a building. If you look at these, it would be your cultivated lands, or it would be anything that you can identify the shape. If it's winding like this, we can see that because of the tone that is gray, we can say there is a river that is flowing there. So the shape would give you a general view on how an object looks like. Textures refer to the arrangement and frequency of the tonal variation, particular areas of an area. So you would find that the certain texture would appear to be rough, like in this instance. But when you look at comparatively the other part of this map, the texture in this block and this, it's not the same. So texture refers to the arrangement and frequency of the tonal variation in particular areas. So we find areas that are covered with vegetation and those areas that would have your cultivated lands. So the texture between a cultivated land as well as an area covered with trees or bushes would have a different texture, the rough and the smooth texture there. Association, the identification of features that one would expect to associate with the other. So we would look at certain features that would associate. We know that when we're looking at something that is in a linear pattern there, we would identify it and associate it to linear patterns. And we can also look at some of the features that would show that it's in terms of the identity here. These buildings are large buildings that we can find within one area. The small houses that we can identify here, the association, it can also give us an indication that this would be a residential area. Then size, the size of object in an image is a function of the scale. So scale of the photo would determine the size of how we view this object. Right, okay, here, boys and girls, quickly, I'm going to just show you how we refer to bringing all two together. So when you have a topographic map in this instance and you have an orthophoto map, for you to be able to respond to some of the questions, you must be able to bring all two together. So when you look on the on this map and the orthophoto, what we can identify on either side, that this is the power station. And where do we find it on the orthophoto? There, that's where it is. So using the shape and the association and all the things that I have mentioned in the previous slide, that's how you are able to identify or bring all two together. And then the other example, it's the area that we can identify in the blue circle, which is representing the mine dump there. So we can bring all two together by looking at the shape that we can find around these features, that we can be able to say that this part is this part here. When you look at this shape and the pattern here, we can see that this is the same area that we can identify, which says the previous slides are very important when you're now doing all two together. Right, there is a video that I want you to listen, and that will bring us to the end of our...
So let's now go towards Johannesburg, and let's look at a vertical aerial photograph of Johannesburg. So here what we're seeing is we're seeing Johannesburg, and we're looking at Johannesburg as seen from above. And notice now in the insert map what Johannesburg looks like on the topographic map, and let's compare it to what we see on the aerial photograph. Now let's go a bit closer, and now we're going to go to Carlton Center, which is roughly about this in the CBD of Johannesburg. And notice here again it's a vertical aerial photograph, and what we're seeing is we're seeing directly above, and notice how the buildings are standing out. And look here in the insert map, it shows what this looks like on the topographic map. Notice how the shadows can help us to see at what time this photograph was taken. Because the shadows lie towards the southeast, it tells us then that this photograph was taken in the afternoon. Now let's move further out of Johannesburg, and we're going towards the sporting precinct, and that is Ellis Park area. So can you see, there we see Ellis Park, and we see the surrounding suburbs. And notice now in the insert map what Ellis Park looks like on the topographic sheet. Now let's move further, and we want to now look at, instead of a vertical aerial photograph, let's look now at an oblique aerial photograph, a high oblique aerial photograph. Can you see, we don't see much of the horizon, but what the advantage of an oblique aerial photograph is that we can see the heights of buildings. And so we can see there are tall buildings. We see Carlton Center, there's the tallest building in the picture to the right. And notice how the tall buildings then stand out much bigger closer to the camera, and they become smaller as you move further away from the camera. And notice how the tall buildings block out whatever's behind. And so then you will need to have a map with you to see what's behind the building, so that you can make a comparison between the map and the photograph. Notice here too that the shadow is lying towards the southeast, and so therefore this photograph was taken in the afternoon. Now let's go back to Ellis Park Stadium. Now let's get a lower angle. Now can you see, now we're looking over the Jeppystown area, and we're looking at the stadium itself. Now notice at the lower angle your horizon seems to be stretched out. Okay, our image is cropped, so we're not seeing the full horizon, but you can see how in the foreground the buildings are tall, and in the background the buildings are much smaller, and you can see much more of the landscape because of a lower angle. And so therefore, can you see with a low angle aerial photograph, you can actually even get to see the horizon if the angle is correct. Now let's make it even lower. And now we're coming as close as possible to the surface as we can. And notice now how it blocks off. When you make the angle too low, especially when you get tall buildings, it blocks off your view, but yet it helps us to see the height of buildings. And so here we see then, this is how we can look at aerial photographs, and the functionality in Google Earth helps us to see exactly how we can go from a vertical aerial photograph and then move all the way down to an oblique aerial photograph, starting with a high oblique and then ending with a low oblique angle photograph.
Okay, boys and girls, I would also challenge you to also use the Google Earth so that you can also personally be able to experience what has been indicated to you there in terms of the Google Earth. All right, that brings us to the end of our lesson. Thank you for tuning in. Have a good afternoon.